Essentially, the James Webb Telescope has outlined the most precise picture of the shocking discoveries made by Proxima B. Join us as we embark on a journey through space to reveal the mysteries of Proxima B and check to see if it might be our next Earth. To begin, let's launch into the immense vastness of space, which makes Proxima B intriguing. This planet exists in the habitable zone of its star, Proxima Centauri. However, this planet isn't just any ordinary rock. Proxima B, Earth's relative, is located 4.2 light-years away from us, shrouded in secrecy and wonder. Could there be another Earth with life flowing across its seas and surface? But there's more beneath. In this system, Proxima B isn't alone. Orbiting the red dwarf star, it has a single companion, Proxima Centauri SE, which could reveal additional secrets. The system may even contain undiscovered companions. The mystery doesn't end there. Proxima Centauri produces virtually the same amount of energy from its star as Earth does from the Sun. This may indicate that there is water on its surface, and possibly, life as we know it. As we venture farther into space, we encounter something completely different, exoplanets. These planets orbit stars other than the Sun. There are billions of stars in the Milky Way alone, and the opportunities for exoplanets are endless. Some even wander space untethered to any star, like cosmic rebels. Among the pioneers, Proxima Centauri B stands out as an incredibly fascinating and baffling planet. A year on Proxima B lasts only 11.2 Earth days. Its star is much closer to it than the Sun is to Earth, meaning one side of the planet is continuously bathed in light while the other remains in timeless darkness. Now, let's examine Proxima Centauri, the star that forms part of the Proxima B system. It belongs to a triple star system, along with Alpha Centauri A and B, part of the Centaurus constellation. These are the third brightest stars in the night sky. Alpha Centauri C, also known as Proxima Centauri, is an M-type, red dwarf, star discovered in 1915 by Scottish astronomer Robert Thorburn. At 4.24 light-years away, it is the closest star to our solar system. Proxima Centauri means the nearest star in Latin. Despite being the closest, it remains invisible to the naked eye due to its apparent magnitude of 11.13, which is beyond human vision. However, that doesn't diminish its significance. Studying red dwarfs like Proxima Centauri is crucial because they are among the most efficient energy producers. Though they may not produce much light, the process of convection at their cores allows them to shine for trillions of years. In fact, Proxima Centauri will remain a main sequence star for an additional 4 trillion years. However, the habitability of a red dwarf star like Proxima Centauri is still debated. One major concern is that it is a flare star, meaning it undergoes regular and intense bursts of radiation. The habitable zone around such a star is much closer than the Sun's, likely between 0.03 and 0.54 astronomical units. However, even within this zone, conditions might not be stable enough for liquid water to persist. Without stability, life would be exposed to harsh space weather, making survival extremely challenging. So, despite Proxima B appearing terrestrial, it may not be capable of supporting life. Still, many scientists remain hopeful. One instrument that has drawn significant attention is the James Webb Telescope. After several delays, it finally went live in 2018 and is now aiding in the search for life on Proxima B. However, as with all science, things are rarely clear-cut. Adjustments were needed to ensure that the James Webb Telescope delivers precise images. As Harvard theoretical physicist Avi Loeb explains, if a planet like Proxima B absorbs light from its star, it can also emit infrared radiation. The James Webb Telescope was specifically designed to detect infrared light, allowing it to capture images of this radiation and search for patterns that might indicate the presence of water or an atmosphere. But what if Proxima B's atmosphere isn't conducive to life? The presence of an atmosphere alone doesn't guarantee habitability. Princeton University astrophysicist Ed Turner warns that Proxima B could be more like Venus, a planet with a dense atmosphere, leading to scorching temperatures that make life impossible. The quest to uncover the truth about Proxima B is not without challenges. While the James Webb Telescope holds great potential, there are significant cost-related considerations and increasing pressure from the scientific community to study planets like Proxima B. The stakes are high, but the potential rewards are even greater, the chance to explore the unknown and decipher its mysteries. A system that could harbor life is a pursuit any reputable scientist would follow. But could we ever travel to Proxima B? As the closest exoplanet to us, it presents a fascinating possibility, almost like exploring our own backyard. Even more intriguing is that it is nearly the same size as Earth and lies in the habitable zone, suggesting that it could indeed have conditions suitable for life. Additionally, Proxima B's proximity makes it a prime target for our search for extraterrestrial life. At just 4.2 light-years away, it is an excellent candidate for interstellar missions. Imagine the possibility of exploring this Earth-like exoplanet. However, while the idea is exciting, we can't go there just yet. Future missions may make such a journey possible as technology advances and space travel becomes more accessible. Proxima B remains one of the most exciting prospects in space exploration. However, interstellar travel is no simple feat. To put things into perspective, Voyager 2 would take 75,000 years to reach the Proxima Centauri system. That said, alternative proposals have emerged, including the concept of solar sails, extremely thin, lightweight sails that could harness solar radiation pressure to propel a spacecraft toward the Alpha Centauri system. With projected speeds of 10% to 20% of the speed of light, this technology could significantly cut down travel time. However, even with solar sails or other advanced propulsion systems, the challenge of interstellar travel remains immense. The vast distances between stars mean that even the fastest theoretical spacecraft would take decades, if not centuries, to reach Proxima B. Additionally, communication delays would make real-time exploration difficult. Despite these challenges, scientists remain optimistic. Projects like Breakthrough Starshot aim to develop tiny, lightweight probes that could be accelerated to a fraction of the speed of light using powerful laser arrays. If successful, such probes could reach Proxima B in just over 20 years, sending back valuable data about its atmosphere, surface, and potential habitability. But what if we could go even further? Some theoretical physicists have proposed concepts like warp drives, which could theoretically allow faster-than-light travel by bending spacetime itself. While still far from reality, these ideas continue to inspire both scientists and science fiction enthusiasts alike. For now, our best hope for understanding Proxima B lies in telescopic observations and indirect measurements. The James Webb Space Telescope, along with future missions like the European Space Agency's Plato, planetary transits and oscillations of stars, and NASA's Habitable Worlds Observatory, will play a crucial role in studying this fascinating exoplanet. By analyzing its atmosphere, searching for biosignatures, and refining our understanding of its climate, these missions could help answer one of humanity's most profound questions: are we alone in the universe? Regardless of the outcome, Proxima B represents more than just another exoplanet. It symbolizes the next step in humanity's cosmic journey. Whether or not it harbors life, its discovery has already reshaped our understanding of the universe and fueled our collective imagination. As we continue to explore the cosmos, one thing is certain: the quest for new worlds is only just beginning. A journey to the Alpha Centauri system could be limited to just 20 years. The discovery of Proxima B has rekindled humanity's fascination with space exploration. We now have renewed optimism that the universe is not ours alone. The James Webb Telescope is a marvel of modern technology, capable of taking us back to the very beginning, 13.7 billion years ago. This is the tightly guarded secret: the length of an object's journey increases with distance. Light takes time to reach us, which signifies that the James Webb Telescope can observe objects farther away than any previous telescope. Additionally, it can identify these objects using infrared light with longer wavelengths, allowing us to see distant stars with greater clarity than ever before. This is one of the most amazing benefits that technology offers: insights into the possibility of life on other planets, such as Proxima B. However, like everything else, there are some notable restrictions. The existence of an atmosphere does not always guarantee life. Proxima B's conditions might be similar to those of Venus, with a thick, toxic atmosphere. But get this, such conditions can be detected by the James Webb Telescope. If only 5% of the planet's dayside brightness is visible, the telescope can still analyze it. Although 5% may not seem like much, it is crucial when working with a star significantly less bright than our Sun. Could intelligent life forms on Proxima B be employing bright orbital mirrors to reflect the daytime rays of the star? How cool is that? Numerous exoplanets exist in our universe, waiting to be discovered. These planets come in various sizes. Some are enormous gas giants, while others resemble our own Earth. One type of exoplanet that has caught space scientists' attention is the gas giant. These planets have structures similar to Saturn and Jupiter but are considerably larger. These monstrosities, dubbed super Jupiters, surpass even the largest planet in our solar system. But that's not all. There are also gas giants known as hot Jupiters, which orbit extremely close to their host stars. These planets thrive in sweltering environments with temperatures high enough to melt metal. Imagine being able to observe such a planet up close, with its ferocious storms and extreme heat. In addition to gas giants, Neptunian exoplanets have also been found. These planets are comparable in size to Uranus and Neptune. Among them are hot Neptunes and mini-Neptunes, which are smaller and closer to their host stars compared to their gas giant counterparts. These planets remain shrouded in mystery, making their environments difficult to study from a distance. However, we should not ignore Earth-like exoplanets. These planets resemble Earth and range in size from slightly smaller to twice as large. Additionally, there are super-Earths, which have masses more than twice that of our planet, yet remain lighter than Neptune. One of the most fascinating exoplanets recently discovered is Proxima Centauri b. This planet orbits its namesake star and falls into the category of Earth-like exoplanets with a temperate climate, meaning it could potentially support liquid water. Researchers believe it might be habitable, given its proximity to its host star. Proxima B's potential to sustain life has made it the focus of intense research. Despite residing within its parent star's habitable zone, many uncertainties still surround its atmosphere and overall habitability. One major challenge Proxima B faces is the intense solar flares from Proxima Centauri. These flares could strip away the planet's atmosphere over time, making it more difficult for life to thrive, much like what happened to Mars. The presence of a magnetic field on Proxima B would play a crucial role in protecting its atmosphere. Without this protection, the planet may encounter difficult conditions that impede the development of life. Despite these challenges, scientists remain hopeful. Advances in technology, such as the James Webb Telescope, continue to provide new insights into Proxima B's atmosphere and whether it could contain the necessary conditions for life. The telescope can analyze the planet's atmospheric composition, searching for key chemicals that might indicate biological activity, such as carbon dioxide, oxygen, or methane. Even if Proxima B cannot support life, the discovery of numerous Earth-like exoplanets in habitable zones around distant stars opens up new opportunities to find life beyond our planet. The search for exoplanets is one of the most exciting fields of study today. The vast number of stars and planets in our galaxy suggests that life may be more prevalent than we once thought. Although we are far from reaching these distant worlds, the quest for knowledge about our universe is a journey worth taking. Right now, Proxima B remains one of the closest and most captivating focuses in the search for extraterrestrial life. As technology advances and our understanding of planetary habitability deepens, we come one step closer to answering one of humanity's oldest questions: are we alone in the universe? The exploration of Proxima B and other exoplanets is just the beginning. The coming decades may bring significant discoveries that transform how we perceive life beyond Earth. As our technology advances, our ability to explore and understand exoplanets like Proxima B will improve significantly. The James Webb Space Telescope is just the beginning. Future space observatories, such as the upcoming Extremely Large Telescope, ELT, and the Habitable Worlds Observatory, will push the boundaries even further, allowing us to analyze exoplanetary atmospheres with unprecedented detail. One of the key questions scientists hope to answer is whether Proxima B has a stable, life-supporting environment. If its atmosphere has been stripped away by stellar radiation, then life as we know it may be impossible. However, if it possesses a strong magnetic field or a thick atmosphere that shields it from solar flares, the possibility of habitability remains. By studying the planet's climate, surface conditions, and potential biosignatures, researchers may soon determine whether Proxima B could support microbial life, or even something more complex. Beyond Proxima B, thousands of other exoplanets have been discovered, each with its own unique characteristics. Some are water worlds, believed to be covered entirely by vast oceans. Others are rogue planets, drifting through space without a host star, yet potentially harboring internal heat sources that could sustain life beneath their icy surfaces. One of the most intriguing possibilities is the existence of Earth-like exoplanets in multi-star systems. Unlike our single-star solar system, many planets orbit two or more stars, creating complex and dynamic environments. Could life evolve under the glow of two suns? If so, how would these conditions affect biology and planetary climates? As we continue our search, scientists are also developing methods to directly image exoplanets. Most current discoveries rely on indirect detection methods, such as observing a star's dimming as a planet passes in front of it, the transit method, or measuring slight gravitational wobbles caused by an orbiting planet, the radial velocity method. However, next-generation space telescopes will be equipped with advanced coronagraphs and star shades, blocking out starlight to reveal planets in greater detail. The search for life beyond Earth also extends to moons. In our own solar system, moons like Europa, Enceladus, and Titan are strong candidates for microbial life. These icy worlds possess subsurface oceans, potentially warmed by hydrothermal vents, similar to the environments where life on Earth may have first emerged. If such conditions exist on moons orbiting exoplanets, the possibilities for life become even greater. Meanwhile, breakthroughs in propulsion technology could bring interstellar exploration within reach. Concepts like nuclear fusion propulsion, solar sails, and even warp drives, once the stuff of science fiction, are being studied as potential means to travel between the stars. Projects such as Breakthrough Starshot aim to send tiny, high-speed probes to Proxima B, using powerful lasers to propel them at a fraction of the speed of light. If successful, such a mission could reach Proxima B within a few decades, providing humanity with its first close-up look at an exoplanet. As we push the frontiers of exploration, one thing is clear: our search for life beyond Earth is no longer a distant dream, but an active scientific endeavor. With each new discovery, we inch closer to answering one of the most profound questions of all time: are we alone in the universe? The coming decades may redefine our understanding of life itself, revealing that the cosmos is teeming with biological diversity. Whether through advanced telescopes, interstellar probes, or even future human exploration, our journey to the stars is just beginning. Proxima B is only the first step in a grander mission, one that could ultimately lead us to new worlds and, perhaps, new life forms waiting to be found.